Hi everyone, it's Coach Fred, and I'm looking at the Linear Models Part 2 video. I'm going to move on, and we've been looking at ways to write a linear function given information in a word problem. Again, I'm calling this a model of the data. We're going to look at real models when we have lots of data in a few days. So a third way that you could be writing an equation is when you're given a word problem that contains a constant rate or speed and a beginning amount. And it can be written in the slope-intercept form, y equals mx plus b, or f of x equals mx plus b. And I actually want to point out that a lot of times we could flip that around and you might say y equals b plus mx. Why? Well, because b represents your beginning amount, your starting amount. And so it kind of makes sense that it should come first in the equation. So here's our example. An airplane 30,000 feet above the ground begins descending at the rate of 2,000 feet per minute. Descending at the rate of 2,000 feet per minute. So you can see that that's my constant rate, which means it's a constant rate of change. And there's the two units, feet and minutes, okay? So assume the plane continues at the same rate of descent. The plane's height and minutes above the ground are related to each other. Okay, so let's think about this. What depends on what? Does the height depend on the minutes, or does the minutes depend on the height? Okay, so hopefully you said the height depends on the minutes, because height will be our y and minutes will be our x, or time. And time is always the x, actually, guys, so that's a nice idea to remember. Okay, so we start at 30 feet above the ground, so I'm going to actually do it as a function, f of x, and I'm going to do it as b plus mx, so 30,000 feet. It's descending at 2,000 feet per minute. So 2,000 feet per minute is that constant rate of change, is my slope. So there's my model. F of x equals 30,000 minus 2,000 x. And I put m there, but x, okay? So it says use your equation to find the altitude of the plane after 5 minutes, to find the height after 5 minutes. So that, nice and simple, you're going to plug in, 30,000 minus 2,000 times 5, which is 10,000. So after 5 minutes, you'll be at 20,000 feet. Okay? All right, so that was the one that you probably should feel the most comfortable with because you did spend time in Algebra 1 doing ones like that. I don't know how many you did where you had to come up with the points. All right, another way for you to look at data and come up with a model would be using a table. Now, we're going to specifically look at a linear model, but tables can provide us with many different types of models, so you want to be really careful. All right, so it says a prom venue charges a rental fee plus a fee per student. The table shows the total cost for number of students at Lakeside Inn. Find a linear model that models the function and the total cost y for x number of students. So they provided us with the x and the y, the independent and the dependent variable. All right, but we need to find a slope. So remember, this would be a really good place for us to do change in y over change in x. So my change in y, it looks like, is going up 300, and it appears that that is a constant rate. Now we told you it was linear, so I can see it really clearly. Okay, they're all going up by 300, whereas the x's are all, they have a change of 25. And I can see that that's pretty consistent as well. So the ratio is 300 to 25, which means that in simplified form, the rate of change is 12. Okay, is 12. So let's actually interpret that. Let's interpret what that means. Remember, the y is the cost, and the x is the number of students. So in context, for every one student, it's going to cost $12. So it's $12 per student. All right, so now we want to write an equation that models it. I look at my table and I don't have a y-intercept. Now I certainly could find the y-intercept, by working my way backwards, but I'm going to use point slope because I just always find that that's a quick way to write the equation. So y minus 1,500 equals 12 times x minus 100. Okay, so y minus 1500 equals 12x minus 1200. And so y equals 12x, what is that, plus 300? Okay, so let's actually talk about that. There's my equation, so I can see that my starting amount is $300. So let's think about how many groups of 25 I'd need to work backwards to get to a y-intercept to be an x of 0. Wouldn't I have to go back 1, 2, 3, 4 sets of 25? Okay, so 100. I could be going back 100, which mean I need to go 4 sets back of 300, which would be 1200. Now the rate of change should still be the same. It should be a ratio. So 1200 to 100 is 12. Where would I be if I went backwards 1200? Well, I'd be at 300. So that's a way for you to find the y-intercept as well, by using the rate of change to find the y-intercept in the table, okay? All right, last thing I want to talk about is actually just the beginning of this problem. This is a try now, but I want to talk about this line right here. So let's read the question. In 1970, there were 160 African American women in elected public office in the U.S. By 1993, the number had increased to 2,332. Let x equal 0 means the years since 1900, okay? So guys, you got to be really careful here. So actually, I want to change that. I'm sorry. I want that to be 1970. Let x equals 0 be years since 1970. So that means for 1970, we would be using the x of 0 and the y of 160. So 1993 would give me 23, 2032. This is actually a common technique to use when you're looking at dates, calendar dates, and you want to start, you don't want to write 1970 on the x-axis. It doesn't really actually even make sense because it's actually years from, years since. I changed it to 1970. I could have left it as 1900. If I left it at 1900, then my points would have been 70 and 93, right? Which would have changed my y-intercept. My slope would have been the same, but my y-intercept would have changed. So I want you to pay attention to that, especially in real-life data where we start the graph at a different point than what the actual date is. It doesn't have to be that exact date. We can use a value as long as we state it. We would have to state that x equals 1970. All right, I'm going to let you use that to find your linear model and predict the number of African American women who will hold elected office in 2010. All right, have a great day.